Right, so we are going to solve this question, which is related to forces. So the question says there are three forces acting on a hot air balloon that is moving vertically. I will just keep underlining. The three forces are weight, force due to air resistance, and the upthrust force. Okay, so I'm just quickly going to show the hot air balloon as kind of a ball. So it's here, this ball. Okay. It descends vertically. Descends means it goes down, right? It's moving downwards at a constant speed. Now, being at a constant speed means that it is in equilibrium. Force of air resistance on the balloon is F. Now, when something is in equilibrium, the total resultant force on it is zero. So let's just talk about the forces acting on it. We have the weight. We will label it with a W. Force due to air resistance has already been given to be F, and upthrust we will just give it a variable U. So when it's going down, the situation is, I have written it down over here, when it's descending, equation will be total downward force equals total upward force, which is, since it's moving downwards, air resistance always opposes the direction of motion. Air resistance will be upward and upthrust is always upward. So this is the equation when it is moving at a constant speed downwards. Now, the question further says which weight of the material must be released from the balloons so that it ascends vertically. Now it is going to ascend, means it's going to go up. Same hot air balloon would be moving up at the same constant speed. Okay, air resistance has already been mentioned to be F, so this is going to be its value. We're still going to use F. Now that it will be moving up, what will be the new equation for the three forces? Again, it will have a constant speed, so it will be at equilibrium. It's moving up because now they are reducing the weight. The downward weight is becoming lesser, which means the downward force should become lesser. So now we have a new downward force, and now we are going to use symbol X for the new downward weight, which is lesser than W for sure. So now the equation will be total downward force, which is the new weight, plus air resistance. Why the air resistance being added here? Because air resistance always opposes the direction of motion. So since the hot air balloon is moving up, the air resistance will be acting down. So total downward force is equal to total upward force, which is just the upthrust. Now, how we go about it next? So we need the value of how much weight has to be released. Look at the two equations and look at the answers. The answers must all be in terms of F. So we need to figure out how much of the weight has been released, which means we need to know W minus X. So all I need to do is subtract equation 2. Let's name this equation 2 and let's subtract this equation 1. Subtract equation 2 from equation 1. And when I do that, I end up getting, let's subtract the left hand sides, W minus X minus F equals, let's subtract the right hand sides, F plus W, F plus U, I'm sorry, minus U. Okay, so we end up getting W minus X, which is the weight that has been released, equal to F, move to the other side, F plus F, which is equal to 2F. So this is our answer, which becomes option B. So that is the correct answer.